You know, every single time you shop online, there's this invisible AI working behind the scenes, making millions of decisions about what you see. But have you ever stopped to think, how does it actually judge what's relevant? Well, we're about to dive deep into the surprisingly complex world of the AI that has to make that exact call. Okay, so let's start at the beginning. It all starts with a seller, right? They've got a product, let's say it's this electric mower here, and they want to advertise it. The platform, maybe it's eBay, pops up some suggested keywords. The seller looks them over, picks the ones they like, sets a budget, and boom, done. I mean, sounds pretty straightforward, doesn't it? But hang on a second. Just think about the sheer scale of it. We're talking billions of items. So how in the world does the platform's AI know that cordless mower is a great keyword, but something like garden gnome is, well, not? And that's it. That's the core of the problem. It's this huge battle just to define what relevance even means. So before we can even get to the solution, we've got to really wrap our heads around the problem. And right at the heart of all of this is this kind of fundamental three-way conflict over relevance. Okay, check this out. This diagram is from an eBay research paper, and it's awesome because it lays out the conflict perfectly. You've got the advertising platform over here, and it suggests keywords. Then the seller comes in and acts as a judge, right? They pick a few. But it's not over yet. The search engine gets the final say. It runs an auction and decides what a buyer actually gets to see. And here's the kicker. Each one of these systems has its own goals, and any one of them can basically veto the others. It's a total tug of war. So the obvious thought is, hey, just train the AI on what people click on, right? Simple. But oh man, that data is just riddled with bias. For one, buyers can't click on stuff they never even see. That's what we call presentation bias. And the AI, it only learns from the keywords that somehow survived both the seller's judgment and the search engine's auction. So here's the bottom line. Click and sales data is a really flawed, incomplete signal. You can't teach an AI what's irrelevant if it never ever gets to see the bad examples. All right, so to get around this massive bias problem, engineers had to build something way smarter. They needed a new kind of architecture, one that could truly understand the deep meaning, the semantics, behind what you're searching for and the product itself. And man, this tech has evolved so fast. I mean, we started with just basic text matching. Super fast, but kind of dumb, you know? It wouldn't know that smartphone and mobile phone are basically the same thing. Then we got models that could learn from how users behave. But the real game changer, the big leap, is neural deep retrieval. This is where we use heavy-duty deep learning to finally understand all that context and nuance. So how does this magic actually work? Well, it's all thanks to a concept called an embedding space. Seriously, just picture a giant magical library. The AI isn't reading words, it's navigating locations. It takes your search query, say running shoes, and an item, like a pair of Nike Pegasus, and it turns them into points on a map inside this library. And the rule is simple. The closer the points are on the map, the more related they are. It's genius. And this is where the two-tower model comes in. It's such a brilliant design. You've got one tower, that's one neural network, that's an expert in just one thing, understanding search queries. Then you have a second tower that's an expert in understanding items. But here's the really, really smart part, step 4. All those item locations in the library, they're calculated ahead of time. They're pre-computed. So when you type in a search, the system only has to figure out the location for your query and then just find the closest items that are already on the map. It is blazing fast, incredibly efficient. Okay, so we've got this amazing, super fast architecture. Problem solved, right? Well, not quite, because what this does is create a brand new bottleneck. See, a model, no matter how clever it is only as good as the data you train it on. And that brings us right back to square one, the problem of judgment. Exactly. This is the multi-billion-dollar question, right? If we know click data is biased and messy, how on earth do we get the millions, or really billions, of clean, perfect examples of, yep, this is relevant, and nope, this is totally irrelevant, that you need to train these powerful two-tower models? Well, traditionally, you've got two options, and honestly, neither of them are great. On the one hand, you can hire a bunch of people to label the data. You get high-quality, nuanced answers, sure, but it's painfully slow, super expensive, and there's no way you can scale that to billions of items. On the other hand, you can just use all that click data. It's huge, it's real world, but like we've already seen, it's noisy, it's biased, and it can actually teach your AI to recommend total clickbait. So you're kind of stuck between a rock and a hard place. And this is where the story gets really cool.
So, if humans are too slow and expensive, and clicks are too biased, what's left? What if you could recruit a completely new kind of judge? What if you use an AI to judge the AI?
This was the big breakthrough idea that came out of eBay. The question was, what if you could just sidestep the whole problem? Forget the slow humans, forget the biased click data. What if you could just turn to a powerful large language model, the same kind of tech behind ChatGPT, and ask it to be your tireless expert relevance judge, to just generate millions of perfect training examples whenever you need them? I mean, think about the advantages here. They're huge. LLMs are insanely fast. They can scale up to label billions of items for just a tiny fraction of what it would cost to pay humans. And maybe the biggest thing? Unlike a team of people who are all going to interpret the rules a little bit differently, an LLM is perfectly consistent. Every single judgment is auditable. It's a game changer.
And the results they got back from their tests at eBay, they were just stunning. Seriously, look at this table. The model that was trained only on the judgments from a general-purpose LLM, that's the one highlighted right there, it was a massive runaway success. It slashed the number of irrelevant key phrases by 68%. And get this, it actually increased sales by 10%. It was literally showing sellers fewer options, but the options were so much better that sales went up.
But here's the crazy twist. The model that everyone thought was going to win, the one they fine-tuned by training it on their own expensive human-labeled data, it was a complete flop, a total failure. It actually ended up recommending more junk keywords and sales went down. This was the exact opposite of what all the existing research suggested should happen. So what on earth happened? Well, it's the classic saying, garbage in, garbage out. It turns out the human training data was flawed from the start. The labels were ambiguous. I mean, what's the real difference between good and excellent? It's totally subjective. Plus, the human reviewers were looking at product images, but the model was text only. That's a huge disconnect, a modality bias. And this is the key takeaway, for sure. When you fine-tune a powerful AI on bad, biased data, you don't make it smarter. You just make it more confident in its own biases. You're just magnifying the original mistakes. This whole insight leads to a much more refined way of thinking about this, something championed by a search expert named Doug Turnbull. And his big idea is this: focus on precision over recall. In other words, make it your top priority to get the answers you do give absolutely right, instead of trying to give an answer for absolutely everything. It's about building a careful, thoughtful judge, not some kind of all-knowing oracle that just guesses all the time. So how do you actually do that? Well, it's a pretty cool 3-step process. First, you give the LLM an out. You literally let it say, you know what, I don't know, or I'm not confident if the call is too tough. Just that one simple change massively boosts the precision of the answers it does give you. Step 2, instead of using one giant complex prompt, you create a whole team of dumb judges. Each one is a specialist. One judge only looks at the product name, another only looks at the category. And then, for the final step, you use a classic old-school machine learning model to act as the head judge. It takes all the votes from the specialist judges, weighs their opinions, and makes one final, really smart decision. So when you put it all together, these powerful two-tower architectures and this really clever AI-driven approach to judgment, you realize this is totally changing how our entire online world gets curated. And this isn't just theoretical. The impact is absolutely real. After eBay rolled out their model based on the general LLM judge, they saw seller dissatisfaction, the number of people complaining about bad keywords, drop by 50%. It got cut in half. That is a huge win for everyone's experience, and it's all powered by simply having a better AI judge. And that really brings us to the big final question, doesn't it? As these AI judges become more and more powerful, as they become the gatekeepers for pretty much everything, the products we buy, the news we see, the information we get, the most important question isn't about the code anymore. It's about the training data. It's about who or what gets to teach these systems what good actually means.